Repentance means that you change your mind about God, about yourself, and about your need.
Hello. What number of moles of oxygen would exert a pressure of 10 atm at 320 Kelvin in an 8.2 decimeters cube cylinder? Now, the gas constant is given here as 0.082 atm dm cube per mole per Kelvin. We'll solve and then to know the correct answer. This is from WAEC 2021. Because pressure is given, temperature is given, and volume is also given, we must adopt the ideal gas equation. And ideal gas equation, PV is equal to nRT. Now we are looking for the amount in mole, the amount of oxygen, that is the number of moles, N. Therefore, we make N subject formula by dividing through by RT, which is the coefficient of N. So RT cancel RT here. Therefore, N is equal to, by rearrangement, PV over RT. N is now equal to PV over RT. So N is equal to, we substitute, what is P? The P value is 10 atm. 10 atm. Now, assuming pressure is not given in atm, maybe it's given in newtons per meter square, or it is given in millimeters, we must convert to atm, atmosphere, because gas constant here has amongst the units atm and not newton per meter square, neither millimeters mercury. So we must convert it to atm, but as it is, we are going direct because the value is already given to us in atm. So the pressure is atm times, what's the volume? The volume is 8.2 decimeters cube, or dm cube if you like. Now also, dm cube being the unit, we are not converting further because the gas constant has in it dm cube as the volume. So we are not converting further, but assuming it is given to us in centimeters cube, we must convert it to decimeters cube. So dividing through by the gas constant, which is 0.082 atm dm cube per mole per Kelvin, times, what's the temperature there? The temperature is 320 Kelvin. Assuming it's given to us in degrees Celsius or Fahrenheit scale, we must convert to Kelvin temperature. But as it is directly given to us in Kelvin, and then we apply it directly. So 320 Kelvin. Now, we look at this. ATM will cancel per ATM. ATM cancel per ATM. This is decimeters cube, and this is per decimeters cube. So decimeters cube cancels per decimeters cube. This is Kelvin here rather, and this is per Kelvin. So Kelvin will cancel per Kelvin. So we are left with per mole here. And when we have per mole here, please look at this. I will explain what we have here. Already by units, the whole units at the numerator side has been cancelled. So we now say it is 1, right? So 1 over, this over is the divisor here. This divisor, this is what we now have here. Over what? This is per mole, and per mole is the same as, this is what I'm saying, per mole is equivalent to 1 over mole, right? Good, it's a reciprocal. So therefore, 1 over mole is what we now achieve. Now, mathematically, A over B over C is equivalent to A over B times C over 1. Hence, 1 over 1 over mole is the same as 1 over 1 times mole over 1, which finally gives us mole over 1. Still, mathematically, any value over 1 is equal to that value or units. Therefore, we have mole as the final unit. Now, this is how the final unit is achieved. So, the mole is equal to, let's now calculate, 10 times, we'll go direct, 10 times 8.2 divided by 10 times 8.2 divided by 0.082 times 320. Now this gives 3.125 mole. mole, 3.125 mole. Now when we approximate this to 2 decimal places, it becomes 3.1, because 5 will go, making it in 2 decimal places. We'll stop at this value here. Therefore, since it is up to 5, we'll take 1 from it, and then to be added to these 2, it becomes 3, right? Good. So the final answer is 3.13 mole. So the mole of oxygen that would exert a pressure of 10 atm at 320 Kelvin in an 8.2 decimeters cube cylinder is 3.13 mole. Thank you.